Hello, everyone. Welcome to our talk. We're going to be talking about what we've learned about being a large in-house customer at Databricks. I'm Suraj Acharya, and this is Xuan Wang. So this talk is about data engineering at Databricks using Databricks. We are going to talk about what we've learned, all the good things and bad things, and hopefully a few of these things will resonate with you and you can take some of these learnings away. We've chosen to touch on a bunch of different topics. Each one of them could be a talk in its own, and we hope to enlarge on them and create blog posts throughout this year on them. If there are, depending on the feedback, so if there are some topics that are more interesting or you'd like to hear about them sooner, please come talk to us. So who are we and why do we use Databricks at Databricks? So our team is called the Data Team. Obviously, a lot of thought went into that name. We're an internal data science team and an associated data engineering team. So we have this lofty mission of creating data sets, tools, and analyses to inform decision making and make our company be more data driven. And so for the purposes of this talk, we'll talk about the pipelines that we've built for product analytics. And we've kind of been on this journey that I'm sure many of you have, where we initially wrote a bunch of Spark jobs to pull out some data and create some metrics and analytics to describe how customers were using the product. People were asking questions like how much time do people spend in notebooks? What's the adoption of Delta? What kinds of Spark SQL query optimization should we focus on to get the maximum benefit for most of our customers? Right? So initially, we just wrote a bunch of jobs to pull these metrics out. Slowly, we created pipelines to pull this data out in a regular fashion. Over the last year or so, the amount of data that we've had to process has increased quite a lot. We've had a whole bunch of growth and adoption. We've expanded from one cloud into two. And also the expectations around the quality of this data has also shot up. So we've had to learn how to productionize these pipelines and these data sets. So that's what we're going to talk about. So just to set some context, this is what we consider in scope for data engineering. Hopefully, most of these pieces will be familiar to you. There's some message logging system where you get asynchronous events and logs. There's some place where you store your data and some set of tables. On top of that data, some giant compute engine where you do transformations on the data. Some dashboarding and reporting, a sandbox area where you can play around with this data, some workflow component, and also these things that are often ignored until quite late, which is CI/CD and data quality. So again, hopefully all this stuff roughly rings a bell. We also did a webinar about a month ago that touches on each of these things, goes into some detail and best practices, which should be useful for somebody who's starting out in the data engineering field or somebody who's thinking about spinning up a data engineering project at their company. So to set some context, some more about what we're doing, we have jobs written in Spark, running on Databricks, in Azure and AWS, structured log events, and scale because numbers are impressive. Just to give you the size of data that we're dealing with, hundreds of billions of records, hundreds of tables, and lots of jobs in lots of different regions and environments. And these are roughly the 5 areas that we're going to talk about. We'll first spend some time on how you lay out your data to get good query performance, some time on testing, then deployment and configuration, and then how do you monitor this to make sure everything is running well. And with that, I hand it over to Xuan.
Thank you, Suraj. OK, so let's talk about the common pitfalls. So those are the problems, basically, when you start to develop a data pipeline on Spark, you are probably going to run into those problems sooner or later, and it's very likely you are going to run those sooner. So to set up more context, let me give you an overview of our data pipeline. So our services are deployed on the cloud. So we collect logs and from our services, and they went through a centralized messaging system. Eventually, those raw logs arrive at some persistent storage. That's where our team kicks in. So in order to process those logs, so we have a Databricks workspaces dedicated for processing those logs. And we set up an hourly job, which will read all the latest files, new logs there, and we use notebooks, clusters, and jobs to process those data and write the processed data to another location. So this looks very simple, but in reality, because we're reading from external systems, so we also need to measure the credentials they want to use in order to access those logs and the permissions around it. And this is good. So the hourly job can achieve a low latency, but it also introduces duplicates. Because some logs may be uploaded twice, and they may arrive at a different time. So in that case, you will have a duplicated record in your log table. Then we have a nightly job, so which triggered every night. It will process the data from the previous day. It will do deduplication, and it will overwrite all the data that could, in particular, could have duplicates created by hourly job. So here leads to the first question. So how actually do we efficiently overwrite a partition that are created by the hourly job? So overwriting table partitions is a very common problem, not only in this nightly versus hourly job setup. So another common scenario is, say you identify some data quality issue in your table, then you fix it, you want to reprocess some historical data. So a naive approach in Spark, like write mode with overwrite, probably won't work well because it takes hours. And what if it's crashing in the middle? You may end up with partial data which corrupt your table. Or you might also want to schedule your job carefully, because if someone starts to read your table while you're updating it, then either they will get some inconsistent data, or sometimes the query will just fail. So what are the type of solution to this problem? So one common solution is a partition swapping. Instead of overwriting the table directly, you write your new data to a separate location to create a separate partition. And when your job finishes, then you just trigger a very simple and fast metadata operation and swap this partition in the table that you serve to your stakeholders. After that, if you feel happy, you can just delete the old data, or you can keep your old data around for a while, so to make sure all the readers that they can finish their job, so you can delete your data safely. So this is like one type of solution to this problem. Another alternative is to use Delta Lake. So if you are following the keynote, so we actually open sourced Delta Lake from the keynote yesterday. So Delta Lake is a transactional storage layer on top of Apache Spark and Parquet. And you can just express this simple API, just say write with the format delta, and saying replace where this data equal to, say, January 1st of this year. So that it will perform a transactional override, and it will only succeed when all the operations are finished. So either you have no updates or you have your complete data. Okay. So now you have your data there. How can you make sure the users of the table are happy with the performance? How can they efficiently filter through all the records there? So the process logs usually have some different types. In this example, the metrics column tells where this log is generated from. If I'm working on the logging system, then probably most of my query will have a filter around the metrics equals logging. Those are, we only care about the subset of the logs that are relevant to my job. So how can we enable this, make sure all the queries are performant? Again, so one type of solution is doing partitioning. So instead of partition by date, you can add additional partitions based on the popular the columns in the filters that people like to use. In this case, we can partition by both date and metrics. So however, it's often very tricky to work with partitions. So for example, you may have too many partitions, which eventually results in lots of small files. And in that case, the metadata operation could be expensive, which will hurt the performance eventually. Or if the distribution of the value in the partition column is not even, so you may end up with skewness problem. So your ETL job may be inefficient. So there could be full-fledged talks around how you choose the partitions, but here are some just rules of thumb, general principle, which we find very helpful. So basically, in general, it's good to partition your data by date. If the volume is large, you can partition by hours. And it's also often a bad idea to partition your data based on some, like customer ID, which could have millions of different values, which will eventually result in lots of small files. A general rule of thumb is each partition should be around like 1 gigabytes. If the partition is large, you have multiple files, then this also means like each Parquet file should be around 1 gigabytes. Okay. So what are the other solutions? So at Databricks, we actually, our products support optimize and data skipping in-house. So the idea is during ETL stage, we care about the ETL efficiency. So we actually don't care too much about the read performance. After all the data are written down, then we can perform optimization on top of it. So before we run optimize, there may be a lot of small files because we want to use a large number of parallelism so that our ETL job can finish faster. Then one of the tasks that optimize does is compaction. It will combine all the small files and create those larger files. But this does not solve the filter problem. The user may still need to scan through every record in those data, which could be expensive. So one additional feature that we have is the data skipping. So we actually, while we compacted the data, we move the data around so that records with same values of the key column actually moved close to each other. And then the statistics are computed from those files. So for example, in this case, I know the metric column in file number 2 cover from like letter G to letter N, which means the logging metric is only possible to be included in file number 2. So I only need to scan this file. So I skip all the other files, which can achieve very good performance. Okay. Okay, so this is great. Those are all the exciting Spark stuff. So the rest talk are kind of focusing more on those like dirty work around your data pipeline. Before I jump into testing, let me just give you more background around the development and the deployment workflow at Databricks. So in Databricks, our jobs consist of notebooks and jars libraries, and also job schedules, schedule settings. All of those are checked in as source code in some version control system like Git. So as a developer, I check out the code, I make the change. If I like, I can also sync it to another development Databricks workspaces if I want to try it out on some semi-real data. After my PR is reviewed and merged, then we use Jenkins to actually trigger deployment of the pipeline to staging. If it works well in staging, then it is deployed to production. So the rest of the talk will kind of really focusing on the different components in this chart. So for example, during development, I want to make sure I have good test coverage so that I'm comfortable my code works and future me or other people are not going to break it. After a code is merged, when we deploy it, we want actually efficiently deploy all the complex components in a pipeline to either staging or production environment. Because we have more than one environment, so configuration management could be challenging. And once the job is running in production, we also want efficiently monitoring the performance of the jobs. So the rest of the talk will cover each of those topics. Okay, about testing. So let me give you actually concrete examples. Let's think about the log ETL pipeline again. So the raw data in JSON format, it has timestamp, it has the message. The goal is I want to process those data, and eventually I want to create a data column for partitioning, and I want to have some event time with timestamp type. In addition, I want to extract some information from the message itself. How can we write this in Spark? It's quite simple. So first, I read the data in format of JSON. Let's assume the input data is also partitioned by date, so I just need to specify this partition I want to read. Then I apply this transformation. So I first pass my messages, then I select a bunch of columns while doing casting and renaming in one go. Eventually, I want to persist data. Looks great. But, I mean, what could go wrong? For example, when we read the data, I want to make sure we actually load the correct input. This example is very simple, but in reality, you could actually list in complex files depending on the input data you have. Then during transformation stage, there are a lot of business logics. I want to make sure UDF is working properly, all the columns have the right type and the name, and the output have the right schema. And eventually, about the writing part, I want to make sure it's really what I want. It has the semantics that I designed to be. So it will actually append data or overwrite data as it was designed. Okay, so how do we actually test those things? So the idea about the unit test is, so basically it's kind of expensive to test the whole piece of code because it have all the Spark I/O operations. So the idea is we break this into smaller classes so that we can have efficient unit test on those classes instead. And based on the read, process, and write patterns, so we have those three type of classes, the source, the transformer, and the sink, to capture those logics. Once we have those three classes, then we can replace this piece of code with another ETL runner, which have a very generic method called process data. Please process the data for this state. Then it will composite all those components together and get the job done. So we have a lot of small classes like this, which is very efficient to write unit test. And especially the ETL transformer is the only place that you have all the business logics, so which can be heavily tested, make sure it really works. So what else? So we have unit test on the component, but what if, will it break if I put it all together? Also, once we have all these classes, the notebook don't have much logic in it, but it still handles like configurations, or maybe pull secrets from some secret vaults and put it into the Spark configurations. Then it initialize a runner. It's just say run this ETL on a couple of days. But your development environment is quite different from the real environment. When this code was deployed to a real environment, do we have all the dependencies needed, or are the secrets valid? So this bottom right diagram shows this test parameters. Usually, we need a lot of unit tests, which cover all the small modulars so that we can fast iteration, but we still need integration tests to make sure this whole pipeline works end to end. So how do we do integration tests? So the idea is we basically treat this notebook job as a black box. So we just deploy this whole thing, run it, and validate either whether the job succeeded and if it have all the expected effects. Then we also have a framework so that we can express this test in the form of in code, so that either developers can, using REST API, just when the test is run, the REST API call will be made to a certain testing environment, and all the notebooks and all the dependency will set up there, and the job will be triggered. Eventually, we will collect the result. This can also be automated by the Jenkins, so that we will actually run those tests before we push anything to staging and production to make sure it's not breaking the pipeline. Okay. To wrap up this section, so basically we write unit tests on those small classes, and we also have integration tests, which integrates with our product with REST API, and this can be automated by Jenkins. Okay. So great, so now I have test coverage, so my change is merged. How can I deploy this into the production? So the challenge of deployment of data pipelines is have a lot of different resources. So the way we do it, we develop this CLI tool, so that we can just deploy a stack of resources in one go. Let's take a closer look. So actually, so what's the requirement of a deployment pipeline? So we will certainly want to reproduce the environment, because we want to know whatever works in staging should also work in production, so that we can be confident to deploy to production. We also want to be able to track the history, so that if anything went wrong, we can efficiently fall back to a previous version. Also, we want minimal operational overhead. The way we solve this is, first, we encode all the resources in terms of configurations as code. And those are version controlled, so we can track history. And we have a CLI tool to deploy a whole stack of resources. And we call it stack CLI, so the idea came from deploy a stack of resources. So if you are thinking about like Stack Overflow type of stack, then I would say I'm really sorry about that. But let's have a closer look at the configuration file. So this is one example of a stack configuration. So in this example, it includes 3 types of resources: the notebook I want to run, the job configurations, and the secrets that are needed for this pipeline. In particularly, in the job configuration, there are also embedded information about the libraries on the dependency, and also all the cluster settings. So the CLI tool will just take this JSON, convert it into valid REST API calls, then manipulate the resources. Okay. So then we can just deploy this whole stack on the data pipeline with this one command. Okay. So to wrap up, so how do we handle deployment? So the idea is we want to combine all the configurations so that we have this one master configuration containing all the information about the pipeline, and we deploy it using the stack CLI tool. So this is also part of the Databricks CLI, and in this Databricks CLI, it supports resources such as notebooks, jobs, and objects from DBFS, the Databricks file system. In addition, we also have an internal version which kind of designed for our internal technologies and infrastructure that we adapt, which can also support like Bazel targets or secrets from HCL. Okay. So great, so we can deploy the pipelines. So what's next? So the problem is when you have many different versions of the pipeline you want to deploy, the managing configuration starts to become a problem. For example, so usually you want to run your pipeline in production, but that's not enough. You want to have dev staging so that you can have proper testing and deployment workflow. In our use cases, we are also multi-cloud, so we need the same copy for both Azure and AWS. And those cloud providers have a lot of regions, so we have like data locality requirements. So actually, we need to deploy this to many different regions, which just create a lot of copies of the same pipeline they want to manage. Each of them may have multiple pipeline deployed to, so eventually you end up with a problem that you want to manage one JSON or YAML files per pipeline and the environments. How do we manage those things? So at a very high level, the solution is just you have a template and you also have environment-specific parameters. And such configuration management is a very common problem. So it's a common problem in services where services need to be deployed to in many different regions. It's also a common problem in provision cloud infrastructures. In our case, we're trying to solve this problem for data pipelines. So there are lots of tools around templating your configurations. And the tool we choose is Jsonnet. So Jsonnet is a data templating tool first introduced by Google, and it's open sourced. So it has a lot of features. So first of all, it's a superset of JSON. So our validated JSON files can be treated as the Jsonnet files. Also, it's a full-fledged programming languages and has a lot of features which closely represent those in the object-oriented languages. So it's very powerful and it's expressive. Let me show you one example of how we manage the templates and parameters using Jsonnet. So in the left top chart, this is one example of the template we have. So we have those parameters of the templates on the top. So one of them is deployment mode, could be production, product, staging, and dev. Also, the number of workers, one of the common parameters that we might want to tweak differently because different region, different deployment have different data volumes, and we want to use different settings. So as you can see in Jsonnet, you can refer to those variables further in your template so that once the values are filled in, you will get the correct template, correct configuration you want. Okay. So, in this particular parameter files, I set the deployment mode to be production and the number of work to be 4. And this is the generated JSON. Actually, is a YAML file, so you can see the job names are properly created, and the number of workers is 4. So actually, I think in this talk, I kind of equivalent to JSON and YAML because so in our pipelines, we use JSON, but YAML is more reader-friendly to be consumed by humans. So all those examples are actually in YAML files. Okay. So to wrap up these sections, so the problem we have is we have this multi-dimensional environment to manage. So different cloud, we have different setting, different region have different volume, which also need different settings. The way we solve this is by templating and injecting parameters using Jsonnet. So Jsonnet is a very powerful language, but it's powerful means it's very flexible. Actually, at the very beginning, it's unclear what's the best coding style for Jsonnet. So we also publicize this blog post around the best practice that we learned around managing templates configurations with Jsonnet. I would encourage you to check it out. Okay, so great. So now all the pipelines are running everywhere. So what's next? So basically, the main question is how do you know your job is working well in production? Here is the monitoring came into place. So for our story, basically we define and monitor our SLAs, and eventually we also build alert upon those SLA misses and also those closed calls. So what's the goal of monitoring? So in short, because we are the data team, the mission of our team is just serve those tables for external for stakeholders, such as product or other engineering team. So the top goal is to ensure the timely and the correctness of those data sets. Means low latency and also should have high quality data. So what are the challenges here in our journey? So we found that there are a lot of literature around what's the best practice monitoring services. There are like 4 golden signals for services. However, it's quite different in monitoring a data pipeline. Unlike services, so many of the data pipelines are transient batch jobs, so all the clusters are gone when the job finishes. So basically, this challenge here is we kind of need to try out different things and eventually figure out our journey. Another challenge is we are growing fast, so we need to have a scalable solution which works for thousands of job runs every day. So usually when you start to think about monitoring your job, the first thing you would care is the failure of your ETL job. If the job fails, someone must take actions to make sure it catch up. However, when you grow, you have more and more ETL jobs, then this actually is not working well. So what do? You only care about the most important jobs. So there might be, you will prioritize the important jobs and be more careful about those job alerts. And there are some jobs which are less loved, eventually will become zombie, and so it's a sad story. But this doesn't work either in the long run, so what happens next? So eventually, when you really scales out, you have thousands of job runs every day, you have hundreds of tables, you want to ensure good quality. So what should you monitor on? So based on our experience, so eventually we realized we should really define and monitor on our SLAs. First of all, we still care about failures and duration of our jobs, because if they are critical to ensuring our SLAs, then we must take actions on top of that. Also, we want to closely monitor our data quality. So those are just 4 very common type of data quality issues. The data could be corrupted. You may have duplicate records, or maybe late or even missing record. All those will affect the correctness of your data. Eventually, it will cause confusions, and it will also cause frictions to be data-driven. So those are definitely the first metrics that you would like to start with. Then what's next? We also care about the user experience of the data set we maintain, so we want to have good query performance. So we have a set of queries that are designed for the type of tables, and we will monitor the performance on those. We'll benchmark the performance and monitoring those. So another very useful metrics that we find are, in general, just the throughput of your pipelines in terms of bytes and the records processed. Also, we find it very useful for some certain slice and dice of those metrics. For example, you may want to count those numbers based on the regions, the services, or cloud, which will give you a more detailed view of the health of your data pipeline. So those metrics like throughput, do you want to actually build an alert on top of it? Probably that's not the first thing you would like to build, but those are really helpful metrics to help us to understand the overall health of the data pipeline. Okay, great. So those are the metrics that we want to collect. So how do we do it? How did we do it? So this is an overview, a very simplified picture of the pipeline we have. So we built a core libraries for collecting metrics from our ETL jobs, so that developers can just use this library in the jobs at Databricks. So all the ETL jobs will send metrics through this library, and this library will send the metric to 2 paths. One path is via the Prometheus push gateway. Eventually, the metric arrive at Prometheus and displayed in Grafana, which is a dashboarding tool. So this pipeline, the goal is to achieve low latency in the metric pipeline so that we can trigger in-time alerts upon any issues in the pipeline. So why do we need this push gateway in the middle? Which is because Prometheus is designed for scraping metrics from long-running services. On the other hand, all the ETL jobs, they are batch jobs, they are transient. So the push gateway kind of just bridges this gap. And another path out of the metrics goals is will be saved to certain cloud storage. And eventually, it will be read back and analyzed and displayed by Databricks dashboard. So the goal of this pipeline is we want have longer retention than Prometheus, because the storage is cheap, actually, you can just keep a really long history of your metrics. So in that case, it enable a lot of complex analysis on the trends or capacity planning for the organization. Okay. to wrap up this last section, so the monitoring, the biggest lesson we learned is we really need to define and monitor our SLAs, and we need alerts upon the SLA misses or those about to misses. And in terms of architectures, we have those two separate pipelines, one using Prometheus to achieve low latency alerts, and the other using cloud storage, which enable more complex use cases on those metrics. So I will hand the control to my colleague Suraj to wrap this up.
Thanks, Xuan. That was great. I'm going to try and quickly summarize, and then we can go to questions. So we first talked about common pitfalls. This is like some tips on how you lay out your data to get good query performance. And then we talked about how you can structure your jobs and have a mix of notebooks and jars to get the best testability and debuggability. And hopefully those tips are useful and you got some insights out of those. So next we talked about like deployment and configuration management, how we take a stack of resources and deploy them using stack CLI, and then use Jsonnet templating to use that same configuration and send it to a bunch of different environments that are very similar but still different. And then lastly, we talked about our philosophy on monitoring, where you first think really hard about what the KPIs are for your pipelines and jobs, and you define your metrics that you want to, that are the most important thing for you for these jobs, learn how to measure them, and then set up alerts around those metrics. And everything else is secondary. You can measure a whole bunch of other things for debugging, but these things should come first. Great. Thank you, everyone. Please send us feedback and questions about this. And of course, we are hiring. Like to remind you, we use Databricks for building our pipelines because not only because we think it's a great product, but also so that it helps us expose gaps in the product and areas of friction. So if you want to help us build the best platform for data engineering in the world, come talk to us. Cool. Thank you. Come over to the microphone.
Hello? Oh my. Is this coming through? I hope so. This
I don't
is
know.
Embarrassing.
Yeah.
What are you all using for your data catalog? And particularly sort of as your number of jobs and data sets increase, how are you all being proactive and what kind of tools are you using?
So Databricks has an inbuilt catalog where it's like a list of all the tables that you can organize by namespace. So we do that, the tables that our team creates have a prefix, and those are the blessed ones. And then there's a bunch of documentation around this. I can see you smiling. Yeah, there are some things coming down the line which will help with this some more. Which what you really want is some kind of lineage tool and something where you can have your customers put in annotations and stuff. Right now, we don't yet have the scale where that's a big problem. And so the Databricks catalog plus having really easy ways of people finding out about these tables helps. Yeah.
Hello. Hi, can you hear me? Yeah. I want to know one detail on how do you collect the throughput metrics? Are there any APIs in Spark, or do you write your own function to collect bytes or number of records?
Xuan, do you want to take that?
Yes. So the question is how we collect the metric in Spark. So actually, currently the library we are working on is quite separate from Spark. So it's basically just an interface for sending metric through other pipelines, so to Prometheus and for cloud storage. So it's not directly integrated with Spark. But in our pipelines, we delegate the how you compute the metrics to actually customize codes in Spark. You can use Spark listeners, or you can use accumulators, or you can write separate Spark job to compute the metrics. So in that sense, it's decoupled.
Yeah, and for the things that you're asking, just the number of bytes in and bytes out, we compute that by hand, essentially.
Yeah.
I have a question about the monitoring part. For the Spark, part we have the Spark UI. There's a lot of logs. So we are now using the Azure Databricks. So how we can export these logs into the Azure log analytics. So we can combine the, so get those log analysis results from the Azure, not in the Spark UI.
Yeah.
So the question is, how can we actually get those metrics from the same way from Spark UI? Is that the question? Yeah.
Now we can get some results or analysis from the Spark UI. So how we can get some similar information, not in the Spark UI, but in the Azure, because Databricks is just one part of our whole data pipeline. We are building that into the Azure Data Factory. So we want to have a combined log analytics solution.
Yeah, so I think that's a requested feature, and it's somewhere in our roadmap. I don't know if our PMs are here. It's not something that we use because we are on both clouds, and so we have things outside of that.
Yeah.
But one thing that we actually worked on is the audit logs are now being sent in Azure. They will show up in Geneva. So we are like working on these different kinds of integrations to get more and more stuff into like these native Azure systems.
Okay. Yeah, we are looking forward to too.
Cool.
How you doing? So I had a question about your local development environment. So you mentioned local development. Does that mean that you guys are banging away your laptops, or does that mean you guys are actually using Databricks itself as your development environment?
So about how we set up our local environment, the answer is yes, we do it in our laptop. Okay. So the unit test, we just use the local mode to run the unit test, and when we want to actually do integration test, we will just, the test itself will trigger REST API. Then it will set up some stuff in actually Databricks workspace to run the integration test. And yes, so also we do have
Python for that, or using like, is there like a Databricks local that you're running? Like, how does that work?
So it's just like it's normal Databricks workspace, but we just make a REST API call to put the stuff there and trigger REST.
Gotcha.
Yes.
Thank you.
I have one question about integration testing. Which data set do you use as input for the integration test? And if you create them yourself, how do you ensure that it's hitting all real-world cases?
Yes, so the integration test we have is like have two types. So one type of integration test is you start from scratch. Like there's nothing there, you set up everything just by, so the test itself will have instruction on how you can set up all those data in your workspaces. Another type of integration test we can have is on some existing workspace with some existing pipeline data. Usually they are the staging pipeline so that we can just run the jobs on actually staging data. Yes.
So the staging data was taken from your production?
It's not like real data, but like basically we have like staging services, so we collect some data from there, which they are all our internal data generated by our internal persona, but we use those pipelines just for staging and testing.
Thank you.
Thanks.
Any more questions? Great. Thank you.
Thank you.